the examples for our quadratic function graphing in standard form. Let's go through each of these and pick out their axis of symmetry, the vertex, y-intercept, domain, and range. Maybe some x-intercepts in here too, but I don't have listed. So we have f of x equals x squared plus 6x minus 9. And we have a blank graph, so we can graph this. Let us, from our knowledge, we can pick out the vertex and go from there. Let's start at a vertex. So vertex, we said, we can use our standard form, remember? The number in front of x is a. The number in front of x squared is a. The number in front of x is b. And this number all by itself is c. So our vertex is negative b. So the opposite of b, since it's positive, it turns negative, over 2 times a. Remember, if there is no number, then it's 1. And it's a positive 1. And then we're going to evaluate f where x is negative 6 times this. All right, so negative 6 divided by 2 is negative 3. So then what I would do with this negative 3, I would plug it in everywhere I see x. So it'd be negative 3 squared plus 6 times negative 3 plus 9. And that would give me my y value of 0. All right. Our axis of symmetry, remember, is just the x value from our vertex. So that's negative 3. Oh, yeah, x equals negative 3. Our y-intercept is 0, and where c is, so 0, 9. Our domain is always all real numbers, and I can denote it by that r. And then our range, this one, a is positive, so it's opening up. So it is our vertex y, infinity. All right, we said it was opening up, so that means that we have a minimum, not a maximum. And on this graph, we can plot some points randomly. We know negative 3 is 0 because that's where our vertex is, and 0, 9. These are just random points selected. So negative 3, 0, 0, 9, negative 5, 4, and negative 1, 4. Plot your points, draw your curve at your vertex, make the turn, and put your arrows. That is the first example. Second example, it already gives a graph for us, yay. So we can still look at our form with the Come on, A. Well, there's no B, so B is 0, and then this is C. Or we can just look at our graph. So where is our vertex? Remember, the vertex is where it makes its turn, and that is at 0, -8. 0, -8. Axis of symmetry, remember it is the x value of our vertex, so x equals 0, and you can see this would be where you could cut this in half and it would be the same, which is what symmetry means. Y-intercept, well, it's crossing right there, so we've got 0, -8 for our y-intercept as well. Domain, all real numbers. And finally, range. This again is opening up, so we're going to start with the y value of our vertex to infinity. Finally, there's 2 more examples on your note sheet. This is the last one I'm going to do. You can do this one of 2 ways. You can use the information we have, just like we did the first one, in order to find these attributes. And you also could put it into your calculator and use the graph just like we did on the last one. Let's use the information we have. We've got this is A, this is B, this is C. So let's start with our vertex. Vertex, remember, is -B. So the opposite of B, +4 turns to -4 times 2 over A. We got a negative. There's not a number. It's a 1, but that negative sign's got to come with it. Then we're going to evaluate or plug in that number to our equation to get our y. So -4 divided by what? 2 times -1 is -2. So that is +2. When I plug 2 in on my equation, everywhere I see x, I get -1. No, I don't. Just kidding. I get 3, actually. Okay. Axis of symmetry is the x value of our vertex, so x equals 2. Y-intercept is 0C. Remember, if it's that whole number, even with the sign. Domain is all real numbers. Let's look what range is going to be. This negative sign tells me it's opening down. So my range when it opens down is going to start with -infinity and go to the vertex y. Oh, that is a bracket because it's included. Remember our domain and range. Oh, whatever. And then is this a maximum or minimum? It is opening down, so we got a maximum. All right, if you are lost doing these problems, let me know so I can find you.